Going on now to applications of polynomial equations. These are word problems. So we'll be dealing with tips to solve problems. We'll review the Pythagorean Theorem and then fitting polynomial functions to data. We'll start off with review of key terms, vocabulary terms, the hypotenuse, the leg, Pythagorean theorem, and right triangle. Before we start though, let's do a little review. So up over here I made a little right triangle. We know it's a right triangle because its angle right there is 90 degrees. So the sides adjacent to the 90-degree angle are referred to as the legs. And usually the letter A is designated to the short leg, B to the long leg, although this is not always followed. And then the side opposite the right angle, side C, is called the hypotenuse. And this Greek fella, Pythagorean, back in the old days, said that if you were to square this side, and if you square this side of a right triangle, it actually equals the square of this side, which leads us to the Pythagorean theorem. A squared plus b squared equals c squared. And that's what they'll be reviewing as we go on. So, a right triangle contains a 90-degree angle. The hypotenuse of a right triangle is the side opposite the right angle. Seems like we just reviewed this. A leg of a right triangle forms one side of the right angle. So again, the short leg is usually A, long leg is usually B, but that's not always followed. And the Pythagorean theorem states the sum of the squares of the length of the legs of the right triangle is equal to the square of the length of the hypotenuse. One of the simple examples is what we call a 3, 4, 5 right triangle. This is 9. This is 16 if you square these. And this is 25. So 16 plus 9 equals 25. Proof of the Pythagorean theorem. We're not going to solve all of these, but we will be going through in some detail the strategy to figure them out. So starting with this one, the square of a number right there plus the number right there is equal sign 240. So we'll put this in standard form. N squared plus n, transpose this, minus 240 equals 0. Now we factor this. And have an n there, n there. And as we look at this, we're looking for factors of 240 that have a difference of 1. So I happen to know that there are 15 and 16. We're looking for a plus in the middle. So this will be a plus. This will be a minus. And then can you see our answers are 15 and a negative 16. So you could have, in a sense here, two numbers that will start off. One of them could be a positive 15, and the other could be a negative 16. Well, I solved that one for you. Here, a scrapbook and a picture probably would have been useful for this too. It has a width, and the length is 3 units longer than its width. So we then say width times length is this, and then you will distribute here. Transpose this over, and then factor it. Now in number 6, I happen to know the factors are 9 and 12. So, let's see, this will be a positive, this will be a negative. So the measurements now are 9 and 12. Even though this one comes out as a negative, we add 3, this is 9, so this one will become 12. The negative 12 that comes out over here, we just reject that, because you can't have a side that's negative units long. Number 7 was actually challenging. And by the way, they don't give me the answers. I had to work these out. I made a picture frame that was 16 by 20. And then there was a width that surrounded the actual area of the picture. So there's my diagram. I think for me was crucial in getting some results. So, what do we know? Well, there's this width here and there, and there and there. So if we take 20 minus 2 widths and 16 minus 2 widths, that will equal our area that we know inside there. So there's the start of it. So this one gets quite tedious, and you just need to FOIL it. Again, I'm not going to do them all, but this is how this one is done. Now, number 8 is the very same diagram, and numbers just change to work out what would be the area that this would produce. Again, you have to FOIL it, put it in standard form, and in fact, let me give you this formula. So again, it gets a little tedious and timely to get it done, but when we FOIL this, we got this. I put it in standard form. Make the numbers smaller. I divided each term by 4. This is also divided by 4, but that's still just 0. And then through careful work, and this depends on your skill of factoring, factored into this. And you might say, wait a minute, you got 2 answers here, a 10 and a 75. Well, notice here it's only 70 feet. So the 75 cannot work. So we reject that. Our answer is 10. Now for number 9, let's go on. 3 consecutive odd integers. This is a review from chapter 2. Well, if the first integer is 3, we could say that is x. The second integer is 5, that's x plus 2. Third integer is 7. These are 3 consecutive odd integers, x plus 4. But now they're saying the square of the first, which is this, so we'll square that one, and the square of the third, which is this one, equals that. So our equation will be x squared plus x plus 4, the quantity squared, equals 170. Again, you're going to expand this binomial and group like terms, transpose the 170 to this side, equal it to 0, factor it, and that'll give you the first number. And there are actually two sets of answers here. One will be 7, and the other will be a negative 11. So 7, 9, 11, and this will be a negative 11, a negative 9, and a negative 7. Both of these sets of answers result in our solutions of this equation. Let me build this one with you. So here we have a wire stretched from the top of a pole to the bottom, and the length of this wire is 34 feet. Now the distance this wire is from the pole is d. Remember, this is a right angle here. And the height of the pole is 14 feet more than this distance from the pole. So here we have a Pythagorean theorem. So what will our formula to solve it be? Well, we're going to square this. We're going to square that. And that will equal this squared. So here's what it looks like. D squared plus d plus 14 squared equals 34 squared. So this just takes time after you understand what's going on, how to solve it. And then again, you will integrate, equal it to 0, factor it, and you get to find out that the base here, d, is 16. So this will be then 16 plus 14 is 30. So those are your measurements. All right, number 14 is similar, but let me set it up for you. To help with strategy for number 11, I made a triangle. That's the nature of the sign. And it is 2 feet taller than it is wide. So there's the width. And now the height is 2 feet taller than the width. Now the area of this sign is 24 feet. So there's the formula for area of a triangle. I would put 24 here equals 1/2, and then W times W plus 2. And the first thing I want to do is get rid of the fraction, so I'm going to multiply both sides by 2. So this then becomes 48 equals W squared plus 2W. And then eventually the 48 is going to come over to this side. And we put this in standard form. And we'll factor that. And here's an easy one. So this is 6 times 8 is 48. And we need this to be a positive and this to be a negative. So our width is 6 and our length is 8. Here they gave us a nice easy one. And again, we'll make a picture for this one. Okay, we set it up. There's a rectangular yard. We don't know the width, but the length is 20 more than the width. And they're asking us to determine the dimensions of the yard if the diagonal, which is this line, is 100 feet. So we have, in a sense, a Pythagorean Theorem problem. This base over here is also W, so we'll look at it this way. So W squared plus W plus 20 squared equals 100 squared. So you expand this, combine like terms, transpose this, equal it to 0, put it in standard form, and those are your answers. And it works out that this is 80 and this is 60. Now, do you remember before I talked about a 3, 4, 5 right triangle? Well, believe it or not, this is one of the similar triangles here. Okay, lots of stuff going on here. Now, I was talking to a colleague, and one of the things we mentioned was how many examples should a student do? And he said, well, some may only need 5, some may need 10. Again, you want to practice reading word problems and then converting it and developing a strategy to get the correct answer. So as I read example 13, they're talking about a ladder that is against the wall. And this ladder is 15 feet from the wall. Now the ladder is 5 feet longer than the height it reaches up the wall. So we could say this is H here. And the ladder is going to be H plus 5. So what do you do with this information? Well, we're going to use the Pythagorean theorem that this squared plus this squared will equal this squared. Or this squared equals this plus this. And I'll leave the solution to you. Number 14. Here they're saying a flower bed is 8 meters longer than its width, or how wide it is. So that's its width. The length is W plus 8. And it will have an area of this. So we're going to multiply W times W plus 8. That's length times width equals 84. And this looks like one we could do easily, so let's just do it. Whip it out here. 2 plus 8W minus 84 equals 0. And we now want to factor that. Well, factors to give me 84, how about a 6 times 14? And you might say, how did I know that? Well, I had worked these out already. And how did I work it out? Well, I grind it out like you would have to grind it out. So this is going to be a plus. This is going to be a minus. Okay? So this comes out as W equals 6. W equals a negative 14. We reject the negative. This is 6. This will be 14. Now, some of you can use arithmetic to try to figure out, using this and this is that. But by doing it by algebra, that's the formula, and that's the skill we're working on. Now, as we look at the right screen, at this is a case where, remember, we could say y for this and y for that this will equal that, and that's actually our formula. So it'll be 2x squared minus x equals x squared plus x plus 8. Now, how do you solve that? Well, again, you have to put it in standard form. So we'll transpose this. On this side, it becomes x squared. Here, this is going to become a negative 2x and a negative 8 equals 0. And this one's easy to do, to factor. By the way, all these have to factor because that's the only way we know so far how to do them. 4 and 2, this will be a negative, this will be a plus. So this will be a negative 2 there, and this will be a positive 4. And we reject the negative. So 4 then would be our answer. And then here, let me read this. So here we're going to set off a Roman candle or a flare of some type. It will shoot up into the air, and then of course gravity takes it back down. The formula to describe this is this right here. So all we do there is put in a 0 where our height is at the ground, and we solve this equation. Now notice you can factor out a negative 16 out of each term, and when you do, you get this. It's one that's easy to factor, and here you get a 5. Here you're going to get a negative 3. We'll reject that one. So the answer is it's going to hit the ground in 5 seconds. And for number 17, after reading it carefully, we're wondering when 45 million barrels of ethanol fuel will be produced. We put a 45 there. Again, bring that over, factor this, and it comes out to 5 years. We're not going to do number 18. That would take a lot of time, and we are just about at 24 minutes. So hopefully this has been helpful. Bring any questions you have into your instructor and the tutoring center.